you have to insert at a given position. For example, you have something like 10 pointing to 30. Again, what you will have as a parameter, if you ask me, what we need to do now. So let's do something like this. This is just for precautionary use case when the head is null. And now the current is at this position. Okay, this is the logic, correct? Only 2 lines. And at the end, as we know, we'll just return the head. So this is our code. So if everyone is clear, then we are good. You have to insert at a given position. Okay, now you have all of you have done the question of insert at the starting, insert at the end. Now I want everyone to think that if you have to insert and the position is also given, how will you insert? Okay. For example, you have something like 10 pointing to 30, 30 pointing to 50, 50 pointing to 70. Okay. You are given the value of position as 2. You are given the value of data as 20. Second question, that this position you want to insert. Okay. So it should be changed to something like 10 should point to 20, 20 should point to 30. Then similarly, this is the input, this is the output. You have to insert at this position. Again, what you will have as a parameter, if you ask me, you will have 3 things. You will have a head similar to what we had before. You will have a data or X, and you will have a position. These 3 things will be given in interview and a function name of type node. Now you have to complete this code. You are given 3 parameters: the head, the data, and position. You are given a linked list. You are given a position. You are given a data. You have to insert it at a specific position. Yeah. Yes, please go ahead writing the code for this, not only the approaches. So we have already defined here 3 things: head, X, and position. What we need to do now? So let's do something like this. Node temp. We need to do this. Node temp is equal to new node, and it will have a value X to it. Correct. If the head is null, correct, we need to do this check whether the head is null or not. Then the head is null. Then we need to see what should be like, and the position. If the head is null, we cannot actually return a null. If the head is null, and inside this we check if the position head is null, but the position that we have to insert is 1. In that case, it's fine. That we'll just insert at the first position. We just return the temp. We just return here temp. Otherwise, what we do? Else. In the else case, we return the head. Why head? Since the head is null, so null will be returned. Okay. This is just for precautionary use case when the head is null. And then the head is null, if the position is 1, these things I think most of the guys are missing. If the position is 1, then you just naturally need to return the temp. Because, and let's say if the head was null and the position was 2 or 3, in that case, there's no elements, correct? So they cannot be insertion in second or third position. At that point itself, you need to return the head, which is done. Okay. Now another use case. If head, you have the proper linked list, but the position is 1. That means now this question gets converted to the question where we have to insert at the beginning of the linked list. Correct. So this will now be converted to something which is, we can say, insert at beginning. Correct. Insert at the beginning of linked list. Now this question has got converted. So how we used to take care of that when you have to insert at the beginning? You need to play with the head pointer. Correct. So what you have done in that condition is that you do this temp.next equal to head. Correct. And what is the new head pointer? Head pointer is now our temp. So you just return a temp from here. Correct. Now for the other use cases where the linked list is also not empty and the position is also not 1, you have to insert a third or fourth position. How you take care of those things? Correct. So again, as we know, you cannot play with the head. Correct. You cannot play with the head. You need to point. You need to protect where is the head pointer. So you need to play with the current or something. You need to duplicate your data. So let's say we are duplicating in this current pointer. You are making this node current as head. Okay. You are running a loop for I equal to 1 till the position value. Since starting from 1, correct, not 0. So we are running till position minus 1. So that we got to know if we are running, if we have to insert at 4th position, we should know at 3rd position. We should end the loop at 3rd position so that we can point that element to the 4th position. That's why we're running till position minus 1. Okay. Simple thing here. Here is nothing where we just need to do current equal to current.next. Correct. If at any point we found out, let's say by default or something, the user has given a linked list of size 4 and you want to insert at 20th location. In that case, you need to keep a check as well that if the current or for any reason have now become null, okay, it has reached the end. in that case, here you can print or something. You can print something like in the message out of range. Correct. Or what? You can print this out of range. Or you can return just the head from here. This will be inside this. If the case the current is out of null. Otherwise, this is fine. Current is going to current.next and it will end here. Okay. This everything is inside for this if condition. Okay. Now this for loop has ended. Now what we want? You have reached till the point. So let's say you wanted to insert something like this. This was your node. And you want to, it was something like this. You wanted to insert at this position. Okay. Now what you did, you started your current from here. At current, you have stopped current for position -1. Position was 3, you stopped your current at this position. Now your current is at this position. Okay. You have to do something so that the new element with the new node should come, this node should point to this node and this node should again point to this node. So because of that, this node will get included. So to took out that thing, we need to do is that whatever is the current, correct? So let's see the figure here as well. So initially, this is current. Okay. Let us see by example. This is 10, 20, 30, 40, and you want to insert 25 in between. Okay. What we want to do? We want to do this current.next. What is this current.next? Current.next. Current.next. This current.next is pointing to 30. Correct. This is the current. Then this current is pointing to 30. Correct. Ideally, initially this temp is 25 and this temp.next is pointing to null. We want this temp.next to point to 30. That's all it will be included. Correct. This should point to this. And we want this, whatever is the ideal value of this current, now from pointing here to point to the new temp value. This is the idea. Correct. So let us write what we want. What we are seeing, only that we will write. So we have mentioned that we want our current.next. Whatever is our current, we want our current.next to be a temp value. Correct. This is our current. We want current.next to be temp value. Now, if you just directly update this, what will happen? This 30 will be lost now. Because initially it was pointing here. Initially it was pointing here, not pointed there. You have to store this next value initially also somewhere. So you need to do this like this temp.next. Initially temp.next was null. This temp.next should have a value of current.next. And then only you can do this current.next equal to temp. This is the logic, correct? Only 2 lines. What we are doing, by example, is that there was AC and you wanted to input a B. Correct. So A was pointing to C. Now you want A to point to B. Now instead of A pointing to C, if you make A point to B, there's no bridge between B and C. C will be lost. Now to keep track of C, what we want is A pointing to C should be converted to B pointing to C. First, once this is fixed, then we can always do A pointing to B. So this is how the bridge will be maintained between all these three. This is what we are doing here. This is very important. That we need to do this current.next to temp. But by doing this whatever was the initial next would have been updated. So we have stored it somewhere in the temp variable. And at the end, as we know, we'll just return the head. So this is our code. What we have done, we have taken an X. We have done some checks for if head is null. If head is null or not, we have done our checks. If the head was null, if the position was 1, then we directly inserted. Otherwise, we return a null. If the position is 1, it got converted to insert at beginning. If the position was not null, then position was not 1, then we reach till the 1 position before to where we have to insert. And if within that, if we reach a null, we just print out of range thing. Correct. No, let's say everything is ideal. We have 10, 20, 30, 40, and 25 we want to insert. So none of the cases will work. It will come to the down thing. We just need to point this variable, this 20 to 25, and we want this 25 to point to 20, 25 to point to 30. Correct. So just that this 20 to 30 point is not left somewhere. We have stored it first. This our temp.next has a value of current.next, and current.next now becomes temp. Correct. So this is the idea how we have solved this. So if everyone is clear, then we are good.